By the way, it looks like I just cut my hair. It may look like it's crooked, but actually my ears are crooked. Look at my see how crooked my ears are. So I used to go off of my ears. So I'd actually in the mirror I'd get my ears level, but then that means my head wasn't. So then my hair was like this. Right. So I cut my own hair. So yeah. And that's an important part of this video. I have no idea why. All right. Okay, so here we go. We already know how to do this. I forgot. I didn't know I hit start. All right. Um, Now they're gonna be looking at trying to find problems with my hair in the video. Here's your document. There you go. Okay. All right. So here we go. Now let me move my there's got to be some adjustments. It's usually like a 3-day process when I cut my hair. I find mistakes here and there. So it's all good. Okay, so what is the period? What do you see right here? This is kind of what's happening today, but then it gets a little bit more convoluted. Not too much more. I don't want to scare you. What's that a picture of? Sine or cosine? Sine. So it is a sine. And by the way, let's all say this word together. Sinusoidal. Sounds like a dinosaur, doesn't it? Here comes a sinusoidal. All right. And the reason that hey, what do I see here? What do I see here? What do I see right here from here to here? What is that a picture of? It's a cosine. So cosine's a sinusoidal. They're essentially the same graph, just shifted. That's why Friday we had an infinite amount of answers possible for an equation of a graph, reversing. So that's why we're building on that. All right. So anyway, we'll do the sign because I see the sign. It's unshifted. I saw the sign. Anyone know that song? All right. All right. So what is the period? 2. Let's just get this over with then. B is 2 pi over 2. That's what B is, 2 pi over the period. And yes, when you have real world questions, like 2 might represent 2 seconds, right? 1 second, 2 seconds, the cycle's over. Remember, I said that word cycle comes up in the next thing. All right, I guess I'm just going to squeeze this down here. There's not much room there. So y equals, what's our A value? First of all, what's our midline value? What's our midline value? We'll fill that in first. I guess I'm going to draw this right here. I'm going to put this right here. What is our midline? -2, that's your D value. And then how high do you go above and below that? 4, that's your A value. 4 sine. And then what is our B value? I just found that to be pi, and then I don't have this shifted. So it's X. So that's what f of X is. That's an F. I don't know what happened there. All right, and then how do I guess I kind of screwed this up last hour. I got this on the calculator. We'll get to the calculator next. Sine of 100.5, which is 100, and then 0.5. So I went ahead and distributed that because some people said that last hour when I typed on the calculator and got a nice even number. Why did I break that up as that? What's 100 pi? How many revolutions is that? We don't have time for this. How many revolutions is 100 pi? Everyone should know right away. 50. That's 52 pies. So what is pi? What does this end up being? 50 revolutions and ends up here. What's the sign of that value up there? 1. What's 1 times 4 minus 2? 2. 2 is the answer. Okay, that's what you'd end up getting there. And then we actually typed it in the calculator and started talking about what we have to do in order to evaluate, how we have to set our window, and so on and so forth. But we should be able to understand what I just did there. Okay, now it's going to be awkward during the video because I'm going to make my students read, and we're just going to sit there and let them read. Read your own paper. Don't read up here. You shouldn't be looking up here. He's looking at the ceilings over there. He still can't get over my posters. I had to read and then reread, concentrating more on the numbers. I'm going to go ahead after reading label. Actually, I think the grid, I said this last hour, makes it a little harder. It's almost better without a grid. And I'll show you what I mean when I label the key values. So I went ahead and went from 0 to 15 seconds because I already know some information that's needed. And then went up to 50 feet as this goes by fives. Okay, so I did that, labeled the X and Y axis, sketch, assume the pedals you are measuring goes up on the first motion. Okay, so here we go. Here I am. And then, so if you read this, the pedals are starting in a parallel horizontal position. And then our pedals go like this. One goes down, one goes up. We're concentrating on the one that goes up first. Got it? Okay, so what's the midline distance? What's the midline distance then? And actually, what we're calculating is over time how high this is above the ground. So it's going to be, it's going to go, as you're going around like this. Okay, so what's the midline distance, everyone, from your reading? 29. See, that's what I mean about the grid not being great. So I'm just going to go ahead and mark it right below here. These are probably better without a grid, so those lines tend to get in my way, but that's all right. And then how high? What's the highest point the pedal is going to be? We might as well mark these values. So how high? Who are we going to add to 29, everyone? 16.5. If you don't figure that out, that's the centimeters. That's like the radius. That's how far it is from the center. 29, 39, is that 45.5? I'm going to mark that right there and maybe mark that out here. That's a crucial value, so I just want to make note of it. It's kind of in the way from the 45 and the 50, and just in color coded. Then what's the low point? 29 minus 16.5. Isn't that 12.5? Which is actually smack dab in the middle of 15 and 10. That's nice. And then those are the values I'm going to mark. I have one more piece of information that will tell me what the period is and all the other stuff. And it's the 12 cycles per minute. What does cycle mean? Going one time around, 2 times, 3. So you get 12 revolutions in 60 minutes. So that's what a cycle means. Okay, so you rotate 12 times. So that's 12 cycles per, this is in seconds, 60 seconds. So how many cycles is that? Or how many seconds for one cycle? That's what I want to say. And the answer is what? Okay, no one answered. How many one cycle takes how many seconds? 5. You just have to reduce that fraction. 12 goes into 65 times, so that turns into 1 out of 5. So one cycle every 5 seconds. So every 5 seconds, this is why this works out real nice. Okay, then how does it start? Top, middle, or bottom? Where did that pedal that I'm looking at start at? Middle. Okay, and then it goes up, down, and back up to its original point at 5 seconds, right? So when does it do half of a cycle? Whose is this?
Reagan.
Who?
Reagan.
Ronald? Anyway. Yes. So how many seconds is it? Half of a revolution, like from here to here. 2.5. 2.5. So at 2.5 seconds, you end up here. What's wrong? Is everything okay or no? I had him actually. All right. He was confused by the Ronald Reagan. He knows who I am. He's not a fan of me actually either, so it's kind of funny. Yeah. Does anyone know about him? No. No. Okay. All right. And then what's half of 2.5? Are you okay? You comfortable back there? Get your arms folded, not writing down anything. All right. Half of 2.5 is what? 1. 1.25? Okay, so at 1.25, where are you at? Where are you at 1.25? High, low, middle? High. You're at your high point. And then middle, and then add 1.25. That's 3.75. You're at your low point. Kind of tough to draw. And then this is the distance above, now below the midline, and then back to the midline over 5 seconds. Okay, and then to do another cycle, I really didn't feel like doing this. 1, 2.5. You're back to here, and then you're back to here, and then it's like right around this mark here is the new high point. A little bit after. I'm trying to draw it as a different color so that you get 7.5, 8.5. What was it? 8 3/4. Is that what it would be? Yeah, it looks like it's about the halfway point. Hope I didn't say that wrong. I think it was 8.75 would be that value, and so on and so on and so forth. You get it, right? It's kind of hard to do this one because and this is what I did last hour. This is better. It's like you're better to mark that point as 1.25 comma 45.5. It's better to mark this point that this is at 2.5 seconds, 2.5. The grid's in the way, right? Oh, and I accidentally closed that off. And that's at comma 29 again. It's better to make this 3.75 comma, and then this is the 12.5 low point. And then this is back to 5 seconds, comma 29. So it's better without the grid. Okay, and then we can do one more iteration. You get the points. All right, write the equation. All right, so we got it. What's the period then? What's the period? What's the period? What's the period? 5. No one answered. So the b value is 2 pi over period, which is 2 pi over 5. That's simple. Okay, so I think I could put this in. I got a regular sine curve. What's the amplitude? That's how high and how low it goes from the midline. So what's the amplitude? 16.5 sine. It's not shifted, so it's just 2 pi over 5 x. No shifting right left because at 0 seconds we started this little thing going here. And then the midline is 29. I almost put 30. Just looking at that. Okay, and now calculator active. Let's go ahead and get the calculator out because I think we could calculator active, just plug those in, but then I wouldn't be able to do E yet. We haven't solved the equations, so we're going to have to do this way. I'm going to cheat. No, I'm not. No, I'm not. I'm not going to cheat. I'm good. I got it on. Okay, shoot. Okay, so I have to bring this over here and then go here. But here's the problem, my silly little friends. You have to put your calculator in. Anyone? Radians. This ain't gonna grab, and I'm gonna mess around with you here. Let's try to set up our window. So our window is 0 to 15. So I do like going -1 to maybe like, well, you know what? I gotta go to 23. So I'm gonna go to 25. I just foresaw the future. They asked me to evaluate this up to 23 seconds. So I know the drill there. You got to make sure everything matches. And then what was my low? It was like 12. So I could go 0. And what was my high? 45, 50, right? Was that not quite 50? And then, you know what? What is my mode? I'm in radians. So I'm good. Let's see this graph. Ruh-roh. What did I do? Something happened. Something's wrong. Oh. Okay, here we go. 16.5 sine. Okay, I'm going to go ahead and use the fraction button. No, that's wrong. 1. All right, and then 2. You go too fast. Are you nuts? Slow as molasses here. Molasses. Plus 29. There we go. Okay, that helps. Hey, watch this. You ready? Want to see how bad it is when you're in the wrong mode? Doink, doink. Because 15 radians is nowhere near the same as 15 degrees. Reason you only get that is that represents 15 degrees, well, up to 25 degrees. 15 radians, you have a feel for that now, is a few rotations. 15, I'm sorry, I keep saying 15, but actually 25 radians is more 6, 12, 18, 20. That's four revolutions. Whereas 25 degrees is 25 3/60ths of a revolution. You basically just have 25 3/60ths of a sine curve right there. Because you're not telling the calculator the right thing that you're in radians. I just realized I'm over here. No one can probably hear me. So the video probably just thought I left and nothing was going on. But stuff was going on in the screen, if you could hear me or not. Okay, and then when is the pedal 40 centimeters above the ground the third time? So I'm going to go to this. I'll turn this so you know I'm pressing buttons here. Maybe you can hear me, maybe not. But that's pretty easy. Graph. When is the pedal 40? That's y equals. So I got to put 40. This is what you don't know how to. You have to do this with a graphing calculator right now. You don't know how to solve a graph or 40 here, then what to do after that. I guess you kind of do. But you know, I just like that. The third time, that's really this one right here. Because it goes up, hits it, comes back down, hits it, then it's going back up the third time. So second trace, which is calculate, intersect, and then this is the time you do have to get close to that third interaction there. So you do have to get close, 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 close. That's the third time in this cycle. Enter, enter, enter. Intersection, 5.58 seconds, you'll be at that position again. Okay? And then how high is the pedal after 23 seconds? That's why I did this. You can force 23, 2, 3. That was just trace and then hit 23. We found that out in a video from Flip Math, that's a calculator feature. Okay, so we can force calculate. All right? So after 23 seconds, you should be in that position in the... That's going to be me today. I'm going to be riding my bike. All right? We could write those in. All right, next. Go ahead and read. And the last one, I kept my stuff from last hour. Try to shut up as they read. Greatest movie ever. I don't think I went too far into this one. Okay, so if I plugged in 2 here, I could kind of I could input, say it. I don't need to graph this one. I just plug in 2. 2 minus 4 is negative 2. Negative 2 times pi over 6 is negative pi over 3. What's the sign of negative pi over 3? What's the sign of a 30? 1/2. So what's the sign of a 60? Square root of 3 over 2. Is it positive or negative? Negative. So what I was trying to get you to understand is kind of it could be no calculator, but then what do I do with this? And are you going to tell someone the temperature is in a radical? You're going to give them in radical form? You know, I mean, come on. So, so what this is going to be is you're going to be lower than 61.2 degrees. Why? What does month 2 probably represent in Indiana? What month? Maybe the one that's called the second month, February. All right. Even though today is 50 degrees, this is an average temperature. Tomorrow it's supposed to be cold again. So, yeah, this is going to be a negative number times 25, which is going to reduce this. This makes sense. And then what's the period of this? The period is 2 pi over b. What's 2 pi over 6 become, everyone? 12. Why do you think that is, everyone? There's 12 months. All right. So, therefore, it does work. And then we should be able to answer this question. What is the average temperature? It's one of the numbers in the equation staring you in the face. 3, 2, 1, go. 61.2. How do I know? That's the midline. And that's where the temperatures fluctuate above and below. The midline's the average. You get a certain amount below and a certain amount above the midline. Then I want you to read D and figure out which one is correct. It's kind of like an AP multiple choice question. They give you that formula up there or equation, and then you'd have to say a true or a false. I'd eliminate things as you go. The minimum average monthly temperature occurs at M equals 7 months. Well, if you know Indiana, oh no, I just lost that thing. Oh, there it is. The 7th month is which month? July? Is that where the lowest temperature will be? Kind of already figured this out. What's the answer? A, B, C, or D? A, B, C, or D? Nobody knows? New girl, do you know? It's C. How come you didn't say that when I asked the group response? I don't know either. All right, you got to bust through these walls. Okay. All right, we're gonna do this before we do a regression. So is everyone okay with that one? C. I mean, all the other ones are false. The maximum? No, the average is not the maximum. The maximum average monthly temperature. No, if I plug in 1, I would have got a negative. I just plugged in 2. I plug in 1, I get a negative. It gets smaller. I plug in a 7, it gets larger. It's not a minimum. Crazy. Okay, but then look at this data. I want you to look at the data and try to estimate the period. Don't estimate the vertical shift yet. So look at how the data moves as you go from 0 to 19. Are you thinking, or are you just staring through the wall and wishing you were in the hallway right now? So, everyone, what do you think the period is? 3, 2, 1, go. Answer 4. Okay, good. It is because it looks like from 0 to 4, we go from a high, middle, low, middle, back up to approximately like a high point. Because then when I look after this, it goes from 4 to 8, same idea, high, middle, high. And then from 8 to 12, we got a same scenario, 101, 23, negative 59, 22, 98, hike. All right. I would throw negatives in there if I was a quarterback. Whatever. Okay, so estimate the period. It's 4, right? All right, now we got to do some estimating. What is the vertical shift? What do you think? What numbers in the first 4 things? What 2 numbers represent the possible vertical shift? Is it 97, 24, negative 62, 18, 104? Which ones represent the vertical shift, the midline? What are the 2 numbers I'm working off of? 24 and 18. And then that means all of these represent an attempt at some sort of midline. So these are what the midline or the vertical shift would be. What do you think that averages to be around? 20. I try to get fancy. I think I put 19 once because I didn't like 20 because 20 isn't between 19 and 18, these last ones. But then we just kind of gave up and said 20, right around there. And then how far above or below does it seem to be going? And this is where this is where it gets a little hairy. We can't really find all these averages, but it is right around that number. What does it look like around? Someone said 80. Does 80 seem okay? 80-ish? We tried to get, I think I said like 70. I think I said 72 at one of them because I checked one of them. All right. And then from that, we can create an estimated model. Oh, and then they're mean. They say both sine and cosine. Wait a minute. How does this start from here to here? Is that more cosine like or is that more sine like? Who's more likely to start at the high, then go down and then end up at the high? This does definitely start as a cosine. If you were to graph just the yellow part, this is what you'd be at 97, then 24, then negative 62, 3 seconds back to 18, and back up to 104. So the first thing we're going to do is a cosine kid, and then we're going to think about and you know what? Because I know I'm going to do something different than the other period. So the period's 4, so that means 2 pi over 4 is what b is. Might as well get that. And then the estimated vertical shift, and then the amplitude. What goes here, 20 or 80? What goes in front of sine? Wrong, cosine. What goes in front of cosine? 80 or 20? 80, because it goes 80 up, 80 down, cosine, and then it's 2 pi over, wrong, it's pi over 2. Yoink, yoink. Yeah, I don't know why I didn't just erase. It's pi over 2, and there's no shift on the cosine. And then, except for the vertical, which is up 20 from there. Now, sinusoidal, here's what we're going to do. We're going to go backwards because then we're going to try to mirror what happens on this. But think about this forward. You know, at what y value do I hit like that midline? And that's right around our what value? The 20. That's our midline. All right. But then if I look at this, this is a what kind of sine curve? What kind of sine curve is that? Up, upside down, and that's 1 to the right. So 1 to the left, it would be crinkle, crinkle. To the left, it'd be what? 1 to the left. Sorry, it'd be 1. It'd be the left one, correct? Because last hour, you know what? The hell, heck with it. Right? I'll just do the one right. Everyone's looking at me like I'm a freak, which they're right. I don't care. I want to be normal in this world. Does normal mean in this world anymore? We'll go one right, but then I have to make it upside down. So I'll just forget all about that. If you knew what I was talking about, then this would be +1, and then this would be positive because that's an right side up cosine or sine. So I went one right. I did the pink one or salmon, if you will. Okay. All right. Now here's where you got to be annoyed. Go ahead and do a sinusoidal regression. Go ahead. I already did it last hour. Go ahead and do it. I'll show you what they're doing here at home. I'm not going to redo it. I'm going to go here as they're typing in those buttons. I'm going to clear that last question out. Stat, edit. There it is. I already put them in. Okay. Someone just said, what are we doing? I don't know how to do that. I only did that with linear, exponential, logarithmic, quadratic, quartic, cubic. I've only done all these regressions all year long. Bums. Let's say they don't know how to do this. Okay, I got all the data there. Then for those playing at home, you just go stat, edit, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 19, and then gotta slow down here. Just so you know that points exist in there. Okay, and then what you'll find out is what we had here. By the way, pi over 2, I just want to get you a heads up here. This is going to be amazing. Pi over 2 as a decimal, you should actually be familiar with this. Pi divided by 2, but you're probably not because you don't see it that much, is 1.57 radians. Remember 2 radians? Remember that graphic? 2 radians lands in quadrant 2. Then 3 radians is still in quadrant 2, close to 3.14. So that makes sense. It's close to 2 radians. But anyway, You're all in there. I just want to locate sin reg. I think I'm going to go up. Yes. There's sin reg. It's down below logistic, which we never did. There's exponential reg. There's ln reg. There's lin reg. There's quartic reg. We've done all these regs. Enter. Okay. Now notice what it says. Just talk to one or the other. We had a big thing with this last year. What the heck are these iterations? I know what the word iteration means. But we noticed when we did regressions with sinusoidals, the iterations you chose change the equation, from time to time. And we should probably dive more into it. We may make this a topic of our Wednesday meeting. Get back to this. We'll just tell you what to put in for iterations so that everyone gets the same equation. It depends how much data values you have too. I think that's what it really means as well. But yeah. And then I noticed that they said period here. I think last year we left this blank. But what is the period? I don't think it's going to hurt anything. What's the period? 4. So we can't. Made the wrong thing. 4. And then I'm going to stow. I think it's alpha trace. Store that in 1 and then press enter and calculate. Okay, then there it is. Okay, I want you to, good, I'm glad I left this here. Let's look at our sinusoidal. It has to be sine from the calculator. You can't do a cosine regression because a sine is a cosine graph shifted. So they just said pick one. So they pick sine. Notice this is negative 80. Notice that's positive 80. Why that's positive 80 is what I told you. They went left on their shift, plus C. See it? But here's another thing. How come that doesn't say 1? It's because you'd have to factor out that 1.57. What is 1.57, by the way? I just told you. Pi over 2. So it's got pi over 2x plus this. This technically should say 1.57 as well. But essentially, when you divide these two, it's close enough to 1. A shift 1 left. There's some imperfections in the data. The data is not perfect. So there's imperfections in the graph. Notice our up-down shift, 19.46, not bad. 20 is what we had. So we're almost spot on our B value. And then 80, we're almost spot on our 80 value. So anyway, I just wanted to cover all that before we actually do the math of answering these questions. Now we can answer a whole bunch of them. I can do this. I can turn my plots on. But then what I got to make sure is my data fits the window or window fits the data. I like -1 to 25. That's fine. I don't like my y's. My y's should be, it looks like 105 maybe, and then down as low as, I'll just go -70. So -70 to, let's just do 110. Let's just cover them all and then hit graph. Boom, there we go. So I did the plots of the data. I think the iterations have to be like it depends how your coordinates are and all that stuff. I looked into it last year and I kind of forgot to look at it this year again. But what is f of 30 now? Oh no, did I go to 30 on the window? No, I didn't. F of 30 requires I need 30 there. Then I can force with trace 30. Wrong. Graph, trace, force of 30. Wrong. What do I have to do? I have to turn my what's off. Do you remember? You got to turn your plots off to do that trace feature. Now I can hit trace 30. I'm glad I fumbled with that because I turned my plots on. -60.86731. That's on the downward swing. This wasn't even tied to anything. So, okay. So, all right. We did our estimate. We did a regression. Came close to the same answer. So, and then I can answer other questions. I did show the other one, right? I showed the intersection. I did do this one, right, with the calculator. I'm already forgetting. Okay, the y equals, and then that's what 40 was, so y equals 40. Okay, just wanted to